Good day, everyone. Now we are going to talk about lesson 1-3, dilation and translation of function graphs. So what actually is a dilation and translation of functions, and why is it very important in studying pre-calculus? Now I have two given images here. It's from figure 1-3a of your book, and we have one here and one here. Okay, now we are still concerned about the pre-image function f on the middle. Okay, now we are having this pre-image function f, and we also have this image function g. Okay, so we have two functions here. We have y of x, and we have another function here. Let's call it g of x. Now our y of x is the pre-image function, and our image function is g of x. As you can see, the g of x is somewhat like 3 units away from the y-axis. It's like 3 units away. Actually it is. It's 3 units away from the x-axis, and it's 5 units away from the y-axis. So every portion on the graph of g of x is 5 units away or from the y-axis, and 3 units above or away from the x-axis. Now that's the image function of the function f of x. So we're going to talk about dilations. Now the first example, this one is actually a dilation example. Now what is dilation anyway? Dilation is, now to put it in simple terms, okay, it's simply to stretch or to shrink. But in more technical terms, dilation means being multiplied or in more lexical terms, it's magnified, whether magnified or reduced by some factor. Let's call it A. Okay. So dilation is like just stretching or shrinking. Okay, whereas the second example here on the right, as you can see it, okay, we have the pre-image function f here on the middle, and we have the image function h of x. So let's call it h of x this time. So we have y of x, and we have the other function, or the image function h of x. Now as you can see, the pre-image function seems to retain its original composition, its original, what do you call this? Its original pattern, its original appearance, and just being moved somewhat 3 units from where it's 4 units from where it came from. So from here, it once translated or moved to 1, 2, 3, 4 units away from the y-axis, and 1, 2, 3 units away from the x-axis. So it is somewhat moved. So in other words, when you say translation, translation is in simple terms, it's just to move up, down, left, or right. Moved or shift could be another term for this. So to shift upwards, downwards, to the left, or to the right, that's what you call translation. Now let's discuss this in a more detailed way. Okay, we have our objective here is to transform a given pre-image function so that the result is a graph of the image function that has been dilated by given factors. Notice of the word factors, and translated by given amounts. So it is shifted, it is moved to a certain unit, certain amount, and dilated by a given factor. So first we have dilations. Now as you can see, this pre-image function f of x here, and a given g of x, which is an image function of f of x. Now to get the vertical dilation of f of x, multiply this y coordinates. So it has a y coordinate here. Okay, multiply this by 3 because this g of x here has moved 3 units up. So we will have g of x is equal to 3 f of x. That's the vertical dilation. So this is the more concrete way of illustrating that part. So our g of x now, or our g of x, which is in this case this one, y is equal to 3f of x. In this case, notice the vertical dilation. Okay, so from where it came from here, it was dilated to 3 times from the x-axis. Okay, and now we have the horizontal dilation. We're going to get the horizontal dilation because as you can see, the original pre-image function f here and the image function g here is somewhat seemingly, apparently being a dilation on the vertical and the horizontal direction. So we have the horizontal dilation here. Now if you notice, the original function is somewhat stretched in both directions of the x-axis. So it is 5 units away now. The endpoints of the end coordinates of the x-axis are dilated by a factor of 5 to the positive x-axis and the negative x-axis. That's a horizontal dilation. That's why if our original function, so to illustrate it better, we have this shape here from the original image function. So if our y is equal to f of x, then our g of x would be equal to, this is y1, this is our y2. Then this time we have our x being shrunk and stretched by a factor of 5 since both direction of the graph are stretched 5 units in both directions of the x-axis. Okay, now combining these two, combining the two parts that we got, okay, we have now our f of x, which is equal to, of course, y. Then our g of x will be equal to 3 times f of x, or f of x over 5. Now we could see a vertical dilation here of 3 and a horizontal dilation, which is given by a factor of 5. So in other words, dilation, let's take, in this case, our dilation is equal to a factor given by A and another factor given by B. So that's our dilation format or pattern. Okay, let's make something here. Okay, to make it more creative. Well, dilation, as I've told you, is just a pattern of something like this. So we have the f of x actually is equal to, if you have your graph, now you can verify this. Our f of x is equal to f of x, which is this y, is equal to square root of 1 minus x squared. Now how did we get that?